Hi, bonjour, ou bien plutôt bonsoir. Uh, I'm Ethiel. I'm a senior software engineer at Autonation. I'm a good developer expert for Flutter and Dart. And tonight we're going to talk about clean architecture for scalable Flutter apps. So before beginning, I want to know who have practical experience with Flutter. Okay, that's gonna be fun. Okay, so we are gonna talk about clean architecture for Flutter apps using a case study. So here are my social handles. So before beginning, I have a question for you. I have a question for you. I want to show you so I want to show you a code, and I will ask you what the app is about. So if you can just by looking at the code tell me what the app does. Okay, so this is the okay. Here's the app. Uh, so by looking at the app structure, who can tell me what the app is about? Yeah, yeah. So the app is an app who can help you search for wallpapers, basically. So I have the demo here. So this is the app. Let me restart. So you can browse wallpapers by theme. I think I have some network issues. No, I don't think. But yes, just to show you what the app. So we're gonna talk about how we can structure a mobile app that can be scalable using clean architecture. So why do we need a clean architecture for our mobile app? We know that when you work in a team with a lot of developers, it can be very hard to add new features. So as business needs come and grow, you have to be mindful about how you are writing code and how you are adding new features into the app. And one of the problem is that, especially in Flutter apps, is the UI can be tightly coupled with the business logic, and it can be very, very hard to test, hard to debug. So when a bug occurs in production, how can you ensure that you can fix the bug quickly and push it so that it doesn't impact your business? And by impacting your business, you can also lose money. So it is very important to have a well-defined architecture. So the core idea here is to have some layers into your app, some clear layers which have some boundaries, and each layer has a clear goal, a clear role. And we have some principles we must adhere by when it comes to clean architecture. We have some principles. One of the core principles is the dependency inversion. So I will talk about it deeply throughout this talk. And we also follow some solid principles, but I will not uh, define it here. But you will see what it means throughout this talk. So each layer should only know about the abstractions. We we would not make our components depend on concretions, but we solely depend on abstractions. So what do I mean by abstractions? We'll say it also. So we have mainly three layers. We have the data layer, we have the domain layer, and we have the presentation layer. So we will see the role of each layer, but keep in mind that we have three layers: data layer, domain layer, and presentation layer. So the data layer has a specific role. The data layer is responsible for the data acquisition, how uh, our app can fetch data and maybe store it somewhere, so the other layers can use it and manipulate and display it to our users. So this is the role of the data layer, how our app fetch data. So we can fetch data from an Excel file, for instance, from an Excel file, from a CSV file, or maybe from a server using an API. So it depends on you. So that's why you have the data layer, and the data layer is composed of the data sources and some repositories. So here you can see that I have a repository here, the wallpaper repository here. And I have a data source. The data source here encapsulates the logic of fetching the data from an API. So here, I just fetch the data and I will return it to the repository. So this is the role of the data layer. So far, do you have any questions? Okay. Yeah.
Why would you need abstraction?
Yes, we need abstractions because, for instance, let's say you are working with yes, let's say you are using Sentry for logging and for monitoring your data. Sentry, I think I think you know about Sentry, right? Sentry is a service for monitoring and error handling. So if you make your app depend on Sentry, a specific implementation of Sentry, and you want to switch, for instance, you want to switch from Sentry to Firebase Crash Utilities, for instance, it will be very difficult. But if you, instead of having your app depend on the implementation, this particular implementation, you can create an abstraction like an interface that all your error handler service should adhere by, and you pass that abstraction to the app, and it can make it very testable. You can switch uh, your uh, your error handler service.
I understand, but abstraction is only useful when at the beginning, for example, at the requirement, we have Sentry, we have like crash release, Google or anything, and then we do the abstraction, not when we have only one service and it's going to be only one time, and maybe in the future we're going to abstract it. That's not useful, I think.
I get your point, but I believe that uh, is still necessary to make the app depend on that abstraction. So
You can use it for tasks. So with the abstraction, actually, you can easily more the dependency.
yes,
You can
yes,
test a class, it doesn't matter if it's abstract class or not.
No, because sometimes you wanna simulate like picking a file or server like that, you can hide it and mock the back the answer.
Because if your repository is only working for, let's say, Google image in this example, then how you want to test? When you run the test, you would actually fetch data from Google. But actually, we don't want that in the test because
You
we
use
just want to
the
know.
mocking data and extend it from that class. It doesn't have to be a abstract class. You can mock a class without even being abstract.
No.
Yes.
uh,
Have you
okay, I think we can expand that.
either
Yes. So we are talking about the data layer now. Inside the data layer, you have some data sources. So the data sources is how we retrieve the data. So we can retrieve the data locally or remotely. So here we can retrieve the data from an API, a database, a local file, and it depends on your needs. It depends on your needs. Here, I will show you an example here. So here, this is the contract. All my local all my local data sources should respect. If you want to fetch data locally inside the apps, you must implement this interface. So here we have some useful methods like save the token, the JWT token, save the user model, and here, for instance, if the user logs out, we want to clear the old data. And this is a concrete implementation of the local data source. So here, I'm using a secure storage service to store the user authentication related credentials like the token and other details. So here we can see that each data source has a specific role, and we should not mix the contents of each data source. And what's the key takeaways from here? When you have some clear data sources, you can have your repository clean, because sometimes you can see that inside some apps, from the UI, you can see some people fetching data directly in the UI using an HTTP client. So this is not a good practice, but if you follow this architecture, yeah.
Concerning data sources, they map like, right, what you said, the APIs and the database. So what is how many do you need? You think? Like, for example, if you have your own backend, right, which you build, that one data source?
Yeah, yeah. if you have one backend and you will fetch data from that for only that backend. So you have, yes, you should have only a remote one instance of your remote the data source inside the app.
Like if it does authentication and, you know, the whole, everything that you need is coming from that backend, then you would only have one data source.
Yeah.
So essentially the mapping would be like almost per URL.
E-
One answer.
Not per endpoint, because you can have probably many endpoints, but per like URL, right? Like your backend should be one URL. If you use Firebase, and that would be a separate one.
Yes, yes, yes,
Gotcha.
yes. That's the idea. That's the idea, and you can, if you have multiple uh, data sources, like you have your custom backend, you have from Firebase and from Super base, we can implement a pattern to switch the data sources. Like, let me show you here. This is not a good. Okay. Here in the old, yes, here we can see I have the old remote the data source, which will fetch authentication data and implement the logic. Yes, this is abstract here. And yes, and here I also a data source for Firebase here. Firebase here. So
Sorry, I don't, maybe I'm going ahead, but how do you handle, like, if you have a data source that have, I guess, two, like if you have a local and a remote one for the same, how do you switch between?
yeah, this happens inside uh, your repositories. You Yes, this happens inside your repositories. So inside the repositories, you have to manage the logic of persisting the data. So you can have
That's the beauty of the abstraction. That
Yeah.
you can have multiple data source in one repository. You have full flexibility.
You don't need to know which one exactly, yeah.
yes, for here for instance, you see I have my Firebase remote data source which will get the user information here, and here I have also the local data source here. So inside the repository, I am implementing the catch logic. So after fetching the data, I'm using the local data source here to save the user data from Firebase here. So it depends on your needs and how you want to structure your app. So we are here. So this makes your app repository logic clean, and also you can hide your storage mechanism from other parts of the app, because the storage mechanism is also an abstraction, and everything happens inside the your data sources. So let's continue. Now we have the domain layer. The domain layer, its responsibility is to encapsulate the business rules and the entities. So in standard clean architectures, you also have use cases, but this is my own flavor of the clean architecture, because I think that use cases are overhead for for apps. So I just cut off that part and I only keep this one, the business rules and the entities here. So the entities are like your domain business objects. In our case, it's a wallpaper here. So this wallpaper class represents the business rules, the data we are going to we are going to operate on. Yeah.
I'm just curious, sorry to bombard you, but so the entities, do you have also the equivalent or something similar inside of the data layer where it's like,
Yeah, sure. Yeah,
do you map them?
yeah, yeah. Inside the data layer, we have models. So when we fetch data from the data sources, we create some models, and after we can map the models to entities. No. So inside the domain layer, we have the pure logic. We don't have logic here. So I'm gonna shift quickly to the presentation layer. So presentation layer I think, is the most critical part, according to me, the most critical part of the architecture, because this is the part that interacts directly with the user, and the presentation layer handles user interactions, and also it handles how we move the data from the data layer to the user interface frontier. So here, this is a snippet of the project. Here I'm using Qubit for state management. If you are familiar with block, I think many people here know block, business logic component. Yes, so Qubit is a lightweight version of block. So I'm using Qubit here to manage state. So you can see that when the user interface loads the app, we emit some states. So first we emit a loading state, and then we use our wallpaper repository to fetch the data here. So we fetch our wallpapers, and after fetching them, we emit a new state with the data. And if something happens, an error occurs, maybe you don't have an internet connection, we can emit an error here. And the user interface must react according to your state here. So the presentation layer, as I've said before, is like an orchestrator. So it's like a bridge between your user interface and your domain, and it reacts to user inputs, and it tells the user interface to react to those changes. So let me come here. For the auth qubit, so we have the auth state. The auth state represent the state of the app. So the auth state will handle the authentication logic. So we have a state here to represent the user, the current login user, the login status, the register status, and I have some computed properties to help me know if the user is authenticated, if is authenticating, and so on. So here inside the auth qubit, yes, this is here. Inside the auth qubit, when the user taps on the login button, we emit a loading state for the login status. And here we perform the actual network call here, and we grab the response, and we emit a new state with those results. And if you have an auth exception here, we catch them and we emit the states accordingly. So here, this is a little. So this is a little snippet of the auth state. We have the user data and the login status. So if the user is authenticating, we have this computer property to help us know. So the qubit, so we can replace the qubit by any other state management library. So be it provider, riverpod, block, and so on. So here, the qubit calls the repository, which is from the domain contract. So we call the repository here, and the repository will be responsible for fetching data here. And after fetching the data, we emit state updates. And this helps us keep our user interface clean and free from any business logic, because the main and the only concern of the user interface is to present the data to our users. So if we mix the business logic in the user interface, it can be very difficult to add new features, especially if you have teams with tens or thousands of developers. So here we have an example of how the state is, the user interface is reacting to the state changes from the qubit. So we have a block listener. So the block listener will listen to the auth qubit state here. So when we click on we tap on the login button here, so okay, we reload the app. This is not from here. It's taking time to load. Maybe a network issue. Okay, I will check later. Okay. So when when the user clicks on the submit button to login, the auth qubit will perform network calls with the user's data from the UI inputs, and here in the listener, we listen to the states. So based on the business rules, we react accordingly here. So if you have a successful state, we go to the main to the main page, or if there's an error, we can show a snack bar, or we can even log the error. So here when the user will click on this, the submit button, all those these mechanisms will happen under the hood. So at the end of the talk, I will show you a demo which will show how each layer is each layer is handling its process. Okay, so let's go. So this is the actual data flow. When we land on the login page here, you have the auth qubit, which is hooked on the login page. The auth qubit will orchestrate the state here, and the auth qubit will call the domain layer and will pass to it the necessary parameters for fetching the data. And the domain layer we also call the data layer using the auth repository. And we have our data sources here to perform the network calls and also handle the catch logic here. And here also, the auth repository depends on like some, if you have some HTTP clients here. I have a network client I've created to not depend directly on the HTTP library or the geo library. Let me show. Oh, I will show it later. So this is the actual data flow for the login. So now we'll deep dive into the dependency inversion. So the dependency inversion is a principle that states that higher level modules like repositories or data sources should not depend on concrete implementations. So what does it mean? For instance, here I have the auth remote data source here. The auth remote data source will perform API calls to handle the authentication stuff. And here we can see that I have a network client. The network client is an implementation of this contract here. So here, instead of using this, instead of using the, I don't know, do I have the HTTP library here? Instead of importing the HTTP library, so I'm using instead a network client, which is an abstraction. So you can see here in the I'm looking from the page. Why I have those? Okay, so let's move on. I will find it later. So in practice, the auth remote data source depends on the network client interface, not directly on DO or on the HTTP library. So this can help us swap network clients later if we need. And it can also help us mock easily for tests here. So we can easily inject those dependencies into our software components here. So here we can swap HTTP clients here. We can swap from DO to HTTP or any retrofit if you want. We can also easily test and inject dependencies. And also, this architecture can help us have a consistent error handling across all our requests. For instance, here I have some custom exceptions I'm throwing based on the actual step of the data flow. So here, if an error occurs at the server, I have a dedicated exception: server exception, network exception, cache exception, auth exception. So here, when I'm trying to get the JWT from the local storage, if an error occurs, I can throw a cache exception. A cache exception, and from the qubit, I can react accordingly. So instead of reacting broadly to an exception, I can react to an auth exception, cache exception, and so on. So we already talked about this. Also this. So this is the network client, the DO network client, which will use the DO library for handling network calls here. So it implements the network client contract here. And inside the network related methods, we are using the DO library to perform actual network calls here. And also inside the app, I'm following a feature-first clean architecture. So what's the benefits of the feature-first approach? When I've shown you the app folders, you have been able to tell what the app is about. So this is the benefit of following a feature-first approach. So when you organize our app by features, the developers can easily understand what the app does and not how it's built. So it can also help onboard new developers in the team very quickly. And developers can focus on a single feature at once. So, and if features has its own boundaries and do not depend on other features. So this help your team move very fast. And one of the benefits of the clean architecture and feature first approach is the ease of testing. You can easily test your software components because you are using the dependency injection with abstractions. So I don't have much time left, so I think I can take one question.
Yeah.
Yes, I do have one. And how much time did it take you to build the app?
Here, this
How many, sorry, and how many software engineers were you in your team?
okay. This is a side project. This one is a side project, so roughly 2 weeks. Roughly 2 weeks. This yes. Oh,
How many people were you?
no.
Only him.
Yes, this is a side project. Yeah, yeah, yeah. But okay, thank you. But one of the complaints we have often about the clean architecture is that is very verbose because you have to follow lot of steps. But I think we have some plugins that can help you fasten your process. I think I have. Uh, Let me check it. Uh, I do not have it here, but you have some plugins that can help you create, uh, uh, can help can help scaffold a clean architecture, a folder for your future very quickly. Yeah, 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 yeah. Yes, you have bricks, and in VS Code or Android Studio, you have some plugins you can use if you want to create uh, a new yes, like templates, but there are some plugins that come within the IDE, but I do not have it here. Okay. Okay. Okay.
Any other questions?
I think we can use our break time for questions.
Yes, and I will make the code source available. The code source of this available for
Give us the repository link.
yes. Okay.
Thank you.
Thank you very much.